So this is isomerism in SN1 and SN2 mechanism. You know what are isomers means? The compounds having same molecular formula but differ in their physical and chemical properties are called as isomers. Okay, now. So next, in the structural isomerism is the stereoisomerism. Structural isomerism means the compounds having same molecular formula but they are differing structures. Stereoisomers means the compounds having same molecular formula, same structural formula, but arrangement of atoms is different. Okay, structural isomers means same molecular formula, different structural formula. Stereo means same molecular, same structural formula, different arrangement of atoms. Understand? So in that, this SN1 and SN2 mechanism, that means the conversion of alkyl halides to alcohols, shows optical activity. Optical activity. So what is this optical activity? The process of rotation of plane polarized light towards left or right is called as optical activity. Clockwise direction or anti-clockwise direction. Okay. So in that types are there. One is dextrorotatory. Okay. So what is this dextrorotatory means? Isomers are the compounds which rotate plane polarized light. Plane polarized light in clockwise direction. Clockwise direction, they are represented by capital T or small d or plus. Okay. So another one is levorotatory. Another one is levorotatory. So what is this levorotatory? Of course, the compounds which rotate plane polarized light in anti-clockwise direction. These are represented by capital L or small l or minus. Okay. So here one compound is there. If it is passed through a plane polarized light, either perpendicular or parallel. You know about the plane polarized light, right? So listen here. This type of non-directional light is there. If quartz is placed here, if they move exactly perpendicular to each other, they form this type of lights. This one is the plane polarized parallel, and this one is the perpendicular to this color. These two are perpendicular to each other like that. Understand? One is plane polarized light, another one is parallel, one is perpendicular. Either parallel or perpendicular. That depends upon what? This one. This is a plane polarized that will come in physics, don't bother about it. So listen, if this is the plane polarized light in a parallel direction, if the compounds rotate this light in the right direction, means in this manner, right direction. Correct? This straight is there. If the compounds rotate this direction in the right side, that is clockwise direction, that is textbook. If they rotate the light in the anti-clockwise direction, means in this manner, that is levo. Understand? So this dextron levo substances that shows what? Optical activity. So the main reason that shows the optical activity is enantiomers. You know, I write some concepts are there here. That is one is stereogenic center or chiral atom. Stereogenic center or chiral atom. What is chiral atom? Special means chiral carbon atom you consider. Okay. So is carbon bonded to 4 different groups. If carbon bonded to 4 different groups, then it is called as a chiral carbon. Or you may simply write asymmetric carbon atom. Asymmetric carbon atom. Understand? So I take here example of this OH is there, COH is there, H is there, Cl is there. Here this carbon is attached to different carbon atoms, different groups. Here COH, OH, H and Cl. Okay. So if you write the mirror image for this, what happens? Here C, here it is OH, here it is Cl, here it is COOH, here it is H. So this is the mirror image of this. Correct? If this rotates the plane polarized light in the right side direction of this texture, then this must be O. So if you take this compound, place above this compound. Okay, this LIGO compound is placed above this dextro compound. These two atoms, they may superimpose. OH placed exactly above OH, Cl comes exactly above Cl. But the thing, above H, COOH will come, above COOH, H will come. So maybe these two may superimpose, these two are non-superimpose. Understand? So the non-superimposable mirror images are called as enantiomers. Understand? The next one very important thing is enantiomers. Okay? So what is this enantiomers? Those are non-superimposable mirror images. Non-superimposable mirror images are called as what? Enantiomers. So this is D and L. This one forms enantiomers. L isomers and D isomers. These are called as what? Optical isomers. And the other thing is, last one, racemic mixture. Okay, what is racemic mixture means? Equimolar mixture of enantiomers. Means these two are enantiomers, D and L. If it is 5 mole, this is also 5 mole. If it is 1 mole, this is also 1 mole. The equimolar mixture of enantiomers is called as racemization. Why I explained all these things? Because we are going to explain the isomerism in SN1 and SN2 mechanism. To know that, we have to remember this one. So students, another one thing is, remember this is one carbon atom is with the chirality. So then how many isomers will form? That is explained by 2 to the power of n. For one asymmetric carbon atom, at least 2 isomers can be possible. Okay, so 2 to the power of n. N represents what? Number of chiral carbon atom, means asymmetric carbon atom. Understand? Here 2 to the power of n means 2 to the power of 1, that 2 isomers can be possible. Another one example I will write here. OH, COH, H, C, okay, so listen. This carbon bonded to 1, 2, 3, then complete. 4 different atoms. This is complete one atom. Correct? Atom or a group of atom, we don't bother about it. This carbon is bonded to C, this type of group here. OH here, COH here. 4 are different. So this carbon is bonded to this complete one molecule CH4, Cl and H. Then both are asymmetric. That means two chiral carbon atoms are there. Then how many positives can form means 2 to the power of 2, that is 4. If you write the isomers, possibility of isomers is 4. Understand? If instead of this, if here H is there, instead of this, if here H is there, if you compare this one is completely a chiral carbon atom with the different ones. But here, these two are same. This is not asymmetric, this is symmetric. Understand? We want all the four must be a different compounds. Here two hydrogen is there, then only one chiral atom. This is 2 to the power of 1 means only twice this. Understand? That is CDs are treated times. Understand? So this is all about the terms we are going to use in optical activity, that what we are going to explain in this seminar. That is simple mechanism. Optical activity, in that types are there. Optical activity means the compounds which rotate the plane polarized light. That is optical activity. In that two types is there, dextron and levo. If light is rotated towards right, then it is dextron. If it is rotated towards left, means anti-clockwise direction, that is levo. In the stereogenic center and a chiral carbon atom is there, that means the carbon is bonded to 4 different groups. Okay? And the next enantiomers are there, that is non-superimposable mirror images. This is the and racemic mixture is there, the equivalent mixture of the enantiomers. So this one is the example for that. Understand? So in SN1 mechanism, I'll explain what happened to the isomeric. So students, here listen. SN1 mechanism means tertiary alkyl halide we are going to take. CH3, 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 Br. Correct? This is not a chiral carbon because 3 CH3 groups are there. Understand? This is a symmetric carbon, not asymmetric. So here, listen. If it is treated with OH minus means alkali, any nucleophile, it forms CCH3, CH3 plus OH plus Br minus. This is the reaction. But in the arrangement of atoms, what happens? So listen, here carbon is there. This type of arrangement is there. As in here, CH3, 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 Br. In the carbocation forms, by the removal of this Br, carbocation will form. Br forms carbocation, correct? So then this becomes what? Planar structure. Like this one. Understand? So here it is plus, here it is CH3, CH3, CH3. So student, first assume the OH is bonded from this direction only. Okay? Then here it forms what? CH3, sorry. OH, CH3, CH3, CH. Okay? Consider if OH is bonded from this direction, the opposite direction. Then it forms what? If carbon is there, 1. If this compound is here, that means here it is yes. Here it is CH3. Here it is OH. And these ships here. Here it is CH3. Compared to direction, here it is this side, here it is opposite side, correct? Understand? So if you write these two things, they exactly become the mirror images. What do you think? CH3, CH3, OH here, opposite direction, CH3, CH3, CH3. They exactly become what? Mirror images in the opposite direction. So here what happens? Here from which direction Br is dissociated, in that direction OH is formed, means this is retention of configuration. Means configuration is as it is in the main group. Retention in the configuration. Here what happens? So in the opposite direction of the Br, OH is attached, means this is inversion of configuration. Inversion of configuration. Correct? So when this alkyl halides undergoes nucleophilic substitution reaction in presence of a strong nucleophile, then it forms this type of mixtures. One is the mixture with the retention of the configuration, one is the mixture with the inversion of the configuration, and all the two mixtures are equimolar. If they are equimolar, then what they are called as? If equimolar mixtures are there, then what they are called as? Racemers. Okay, so this entire process takes place along with racemization. So in the last class, in the difference between SN1 and SN2 mechanism I wrote, that undergoes, the SN1 mechanism takes place in the racemerization. Okay, because equimolar mixture of these two products will form. Understand? So here retention of configuration also takes place, inversion of configuration also takes place. But why we consider retention means slight amount. Okay, slightly this product is good. Not that much, comparatively not more, slightly more. Okay, if it is 1 mole, if it is 0.9999 mole means this is approximately 1 means there is not that much different. Or sorry, this is 1 mole, this is 0.999 means comparatively it is not that much different. Understand? Both are considered as what? 1 mole. Understand? So this is all about the SN1 mechanism. This SN1 mechanism takes place with the racemization. Racemization means equimolar mixture of these two compounds. Understand? What are these two compounds? As enantiomers. What are enantiomers? Mixture of D and L isomers. What is D and L isomers? Dextro and levoisomers. That's what I explained before. Understand? Because you have to know only this much. Racemization, that is enough for you. Next one is SN2. Next one is SN2 mechanism. Here, carbon is there. Methyl bromide, H, this one is Br. If it is treated with alkali, it is, so you know how this reaction will take place? Partially breaking and making of bond takes place. Correct? That is the transition state. Later, it completely breaks. H, and bond will form. Always The bond formed is exactly opposite direction from which the nucleophile is detached. Here nucleophile is detached in this direction, product formed is in this direction. Understand? So from here to here, if we consider, this is exactly opposite in conversion. Actually, opposite in configuration. Correct? So this one is called as inversion. So the SN2 mechanism takes place with the inversion of configuration. So this inversion is called as Warden inversion. This inversion is called as Warden inversion. Understand? So this is all about isomerism in SN1 and SN2 mechanism. That's SN1 racemization, SN2 Warden inversion. If you remember that much, that is enough. Understand? So the next one is the preparation and properties of haloarenes. This completes haloalkanes. Now we will discuss about haloarenes. Haloarenes means the halogens are replaced by hydrogen of the aryl group. Aryl means benzene group. Okay, next. Haloarenes, this type of compounds. Okay, so in that, first one is preparation of haloarenes. This is preparation of haloarenes. So two methods is there. One is electrophilic substitution of benzene. One is electrophilic substitution of benzene. Second one is diazonium solid. That is called as Sandmeyer's reaction. These metals which have the ability to carry halogen groups. So then what happens? This Cl2 is there, H is there. I am telling what? Electrophilic substitution means this Cl2 is bonded like Cl plus and minus. Which one is electrophile here? This one is electrophile. The species with a plus charge is the electrophile because from here H plus is displaces. Correct? So H plus displaces means here minus is there. H plus is replaced by this. Understand? So then what happens? It forms in the place of any H is replaced by Cl plus HCl. Understand? So explanation if you want to write, benzene reacts with chlorine in presence of a halogen carriers. Okay? Then they form chlorobenzene. So nomenclature I already explained, so no need, I will not explain it again. This is monosubstituted benzene, that is chlorobenzene. We no need to mention position here. Understand? Similarly, Fe or FeBr3. Okay, then it will form bromobenzene plus H So students, from here only Cl and Br is formed, not benzene with the fluoride and benzene with iodide. Iodobenzene will not form and chlorobenzene will not form. Only chloro and bromo are the stable compounds. Why? Because you know fluorine, it is smaller in size, it is highly electronegative atom. So due to the smaller size, it has high lattice energy. Due to the formation of the high lattice energy, it cannot easily breaks. High lattice energy is there means what is lattice energy means? The formation of ions into a solid content, okay, molecule. That energy is more. If lattice energy is more means it is a strong bond. That is it requires so much of energy to break the bond. Because of the high lattice energy and smaller size, fluoro compounds are unstable. I am not telling they cannot be formed. I am telling they are unstable. Okay, this fluorobenzene may form, but that is not stable. Okay, so instead of Br2, if we use I2, okay, if we use I2, that is also not possible. Why it is not possible? Because students, if I2 is there, that is a good reducing agent. So here iron we are using means it reduces iron into different oxides. So this FeI3 is there. Instead of this FeI3, it is attached to benzene, it forms I2. Understand? So listen, here FeBr3 is there. So FeI3 is there. Here I minus charge, it has the capacity, it is a good reducing agent. So it reduces to I2. Instead of reacting with this, it reduces to I2. Because of the greater reducing character of iodine, this reaction of benzene directly with I2 is not possible. But when this benzene reacts with Ki, then it forms iodo compounds. Means if it is reacts with salts of iodine, then they have the capacity and then this iodo of benzenes will form. But this type of halogen, addition of halogen, the electrophilic substitution cannot form. Understand? So this is all about the preparation of haloarenes from electrophilic substitution of benzene. So that's why I wrote this is not stable. So fluoro and iodo I didn't explain. Only these two are given in the NCERT. This much is enough. How can you write the explanation? When benzene undergoes halogenation in presence of halogen carriers form chlorobenzene. Here chlorine is there. Chlorine we have to use. Here benzene reacts with bromine in presence of a halogen carrier and write FeBr3. So then bromobenzene will form. Understand? So next, from diazo compounds. So what is this diazo compounds? So listen, if the benzene ring is with this type of structure, into X, this type of structure. It may be Cl, it may be Br, whatever it may be. Okay. So, okay, excited. So students here, this because of the presence of this N2 group, they are called as diazo. This N double bond in group is called as what? Azo group. So because of the presence of this N2, they are called as azonium salts. Because this one is plus in charge, this one is minus in charge. Why plus? Listen. Nitrogen maximum capacity is 3 only. Here how many bonds are? 1, 2, sorry. Triple bond it is. 1, 2, 3, 4 bonds is there with the plus charge. If you consider, okay. From both, this is plus charge. Understand? And this X become minus charge. Understand? So that's why this is called as azo compound because of the presence of the N2 group. If this type of diazonium salt is reacts with Cu2Cl2, then if Cu2Cl2 is there, you have to take acid HCl. If benzene diazonium salt plus Cu2 Br2 is there, then you have to take HBr as the acid, the respective acid. Cl you want HCl, Br you want HBr. Are you may taking as students? Instead of the Cl, this L may be same also. If Cl we want, chlorobenzene we want, this is the Cl. Bromobenzene we want, this is the Cl, and this is the reagents. Understand? Cu2Cl2, NCl, Cu2Br2, HBr. So then what will form? Cl plus Cu2. Understand? That N2 group is removed. From here, it is Br2. So this nitrogen is being a gas, is easily escaped. So this reaction is called as Sand-Meyers reaction. Understand? So this is all about the preparation of aloe from electrophilic substitution of benzene and the diazonium. Only two preparation is there. So remember one thing, here also we are not using Cu2F2, Cu2I2. As I told you the same thing, because copper is a metal, it easily oxidizes as well as reduces. So Cu plus 2 irodu, Cu plus 1 aಗುತ್ತೆ, reduction aಗುತ್ತೆ. Understand? In presence of I, in presence of that F, they are good. And fluorine and iodine are good oxidizing and reducing agent. Remember that much. Fluorine is oxidizing agent, iodine is a reducing agent. So that way, due to that nature, these are unstable. Fluorine and iodine with respect to this. Understand? That's why always we used to say chloro, bromo, chloro, bromo in presence of haloarenes. Understand? So this is all about what? The preparation. Next we will study the chemical properties of the haloarene. So before going to study the chemical properties, first we have to write which type of reaction under which position the reaction will take place. Students, this is the benzene ring, okay, with halogen lone pair electrons, correct? So this is an electron releasing group. Cl minus is an electron releasing group because it has a lone pair of electrons. So these two lone pair of electron shifts here and this shifts here. Okay, then what it formed? Single bond. Here it formed a double bond. X is there, two lone pairs plus charge. Okay, so remember, while representing the resonance structure, you have to write plus charge or minus charge inside the circle only. That is the way or the rule to write the resonance structures. So here benzene is there. Listen, here two electrons, bonded electrons are there. It comes here means we got minus this position. Correct? Next, in second resonance, these electron shifts here, these electron shifts here. Okay? Next, this is the benzene ring. Here double bond X is there. Plus charge. So here single bond is there. Listen, here the bond shifts here means here it forms a bond. Here it is minus charge. Correct? In the next, these electron shifts here, these shifts here. That means double bond X plus So here bond is already formed. Here shift means here bond will form, and here it got a minus charge. Correct? At last, this electron shifts here, this electron again goes back here. So then, this will form this type of structure. Correct? So, overall structure, you want to write the hybrid orbital. That is, so here the double bond positions are changed. From here it is, from here. Position of the double bond is changed means the delocalization takes place written in this method. And this is X. Okay. So students, from this, what you are going to observe is that this is the resonance structure 1, 2 and 3. And this is, these 3 are resonance or canonical forms. Canonical forms means representation of the molecule in the different resonance structures. Okay, so this one is resonance hybrid. Resonance hybrid. Okay, so listen. Here what happens with respect to this halogen? This is alpha, this is meta. Consider this is ortho, this is meta, this is para, this is meta, this is ortho, correct? These two positions are ortho, these two positions are meta, this one is para, correct? With respect to this halogen. So students, assume here, at ortho position, para position, minus group is there. Okay? At ortho and para position, minus group is there. That means what? It has the capacity to substitute electrophile, not nucleophile. Minus charge is there. To balance that minus charge, we require plus charge. Correct? To balance this minus charge, we require plus charge. So that's why they undergoes what? Electrophilic substitution reaction. That means what? Here H is there, right? That H is replaced by as what? H plus minus is there. Correct? If instead of benzene, if we take this one, if we displaces this, what will form? CH3 plus will form. This system will get plus charge. But here system is getting what? Minus charge. Understand? So if the chloroalkanes are there, then they undergoes what? The electrophilic substitution reaction due to the formation of negative charge at ortho and para position. And always remember one thing, ortho position is there, para position is there. So in that ortho and para position, always whatever the product is formed, either it is ortho product or para product or mixture of both, ortho and para. And remember, in that which one is major, which one is minor means, how many ortho groups are, ortho positions are there? How many ortho positions are there? 2. Para position is only 1. That means always ortho product is a major product than para. Understand? Ortho product is a major product due to the 2 ortho positions, and para position is only 1 means it is a minor product. So this will show the electrophilic substitution reaction. Another one is that is reaction with metals. As a name reaction is the Fittig reaction and Woods Fittig reaction. Understand? So the chemical reactions we will discuss in the next class. Okay? Anything doubts about it? Understand? This resonance structure only tells about what? Which type of reaction it undergoes. That is electrophilic substitution. So from this resonance we can easily write if positive species attaches means that attaches with the meta position. Plus species. Sorry, means minus species, nucleophile. Yeah, minus is there, this here it will be plus. Minus, plus. That you know. Correct? If here plus is there, that means what? Their nucleophile can attack. Understand? But this shows electrophilic substitution reaction. Understand? So this is all about the chemical property. Thank you.